This is Lecture 8 on the Fiber Optic Association lecture series on fiber optics. This lecture is on fiber optic installation. There are two categories of fiber optic installation: outside plant and premises. And of course they are defined by their names. Outside plant are cables that are installed outside, and premises cabling is installed inside buildings. They're quite different. Let's look at how they're different. Outside plant includes many kinds of applications, such as telecommunications and cable TV. It involves long-distance networks and the internet. It involves municipal networks and traffic systems. And most of these use the same types of installation techniques, while their applications may be quite different. The first type of outside plant installation is underground. Underground is cables pulled in conduit that have been buried underground. It's very important with all outside plant installations to know the installation methods. When you're pulling cables in conduit, you need to know the limits for tension and bend radius, how to attach pulling eyes properly, how to despool cable by rolling it off the spool, and when you have to do mid-span spools, you'll need to know how to figure eight the cable. Long cable runs will generally use powered capstans for pulling the cable because they can be controlled very accurately and limits can be set on how much tension you use. You always end up lubricating long lengths of cable, and it's important to use the right kind of lubricant because not all lubricants are compatible with fiber optic cables. Direct buried cables can be laid in trenches or plowed in using special heavy machinery. Of course, you always use armored cable for direct buried cable because it protects the cable from crushing and from rodent penetration. It's very important to know the route well and do lots of planning before you do direct buried cables. It's especially important to know what kind of cables and pipeline are already buried in the area, because it's very dangerous to dig up, obviously, other cables, or even more so, it's dangerous to dig up things like gas pipelines. There is a number you can call before you dig and find out what is in the area. Just dial 811, a toll-free number, and ask about the area you're digging in. Lots of fiber optic cables are installed aerially. They can be all dielectric self-supporting cables. They can be cables that are lashed to messengers or other cables. Or, as done by the utilities, it can actually be fiber optic cable inside of optical power ground wire, a conductor used for high voltage transmission. Each of these requires special mounting techniques that need to be understood well before attempting an installation. One question people often ask is, how are thousands of kilometer-long undersea links installed? Well, they're installed by paying them out from cable-laying ships. The cables themselves are actually built in factories and laid in large spools on board the ship and then paid out as the ship steams from point A to point B. The cables are anchored on the shore, and interestingly enough, they're usually installed live. They're actually transmitting data so that the condition of the cable can be monitored during the entire installation and any problems fixed before the installation is actually complete. One of the most popular applications for fiber these days in the outside plant is installing fiber to the home. Fiber to the home can be direct buried, pulled underground, or run aerially directly to the house and connected up into a box, an optical network terminal on the side of the house to provide high-speed service to the home. Outside plant runs are often very long, and they will require splicing together cable sections every 5 to 12 kilometers, or even more often for branching. It's mostly done with fusion splicing, and that fusion splicing is generally done in splicing trailers or tents so that the temperature can be controlled and the workplace can be kept clean. After splicing, the splices are protected in enclosures which are then buried for underground installations or suspended in aerial installations, although they can be kept in pedestals or in controlled environmental vaults. It all depends on the application. Here's a typical small splice closure used in a traffic control system with small fiber count cables. Closures must be chosen for the cables and for the environment in which they will be installed. This one will go into a pedestal. Some go into underground vaults. Some get hanged from poles or even cables. You choose the closure for the cable and the application. Most outside plant cables are single-mode fiber and are terminated by splicing a pigtail, a short length of fiber with a connector on one end, onto each fiber, and then terminating in a splice closure. For multi-mode loose tube cables, 250 micron fibers can be direct terminated if they use a breakout kit like this. Fiber to the home led to the development of prefabricated cabling systems for the outside plant. Outside plant cables were terminated on one end with weather-resistant closures with seal connectors on them, and the other end was spliced into the installed cable plant. These can save lots of time in installation and often can save costs. There's as much variety in premises installation as there is in outside plant. You can install cables in modern buildings like the telecom closet in a data center for an insurance company on the left, or in the basement of a 200-year-old building used by a college in New England, shown on the right. In premises installations, fiber optic cables can be suspended from J-hooks, placed in cable trays, or pulled in conduit or fire-rated interduct. It's important to remember in premises installation that all cable must meet local fire codes. If you mix fiber and copper cables, the fiber should be run on top or suspended below the heavier copper cables. There are other requirements of local fire codes that must always be remembered. If you penetrate a firewall or a floor, they must be fire stopped. So all the cables, as you can see here, are either permanently foam sealed or temporarily bag sealed, where they go through the penetrations in the floor. You also have cables coming into the building that, if they're not fire rated, can only go 50 feet unless they're in conduit. So these requirements must be known for whatever the local fire code is, and it does vary according to where you're doing the installation. Prefabricated cabling systems for premises installation have been around for many years. Basically, you use a CAD system to design the cable plant, have it built in a factory, and bring it out and have it installed. In the early days, we tended to terminate the cables and put the connectors inside protective boots to pull them. But today, a lot of the cables use multi-fiber connectors, and they use modules that fit in patch panels that connect up to the multi-fiber cables installed in the backbones. Another option for installing cable, primarily used in premises applications, but has also been used in metro systems and fiber to the home in the outside plant, is to install air-blown fiber. Here you install a cable, which is really a cable of plastic tubes, and then you blow special fiber into the tubes using high-pressure gas. The installation is relatively easy but requires special equipment. We're the Fiber Optic Association, the nonprofit professional society of fiber optics. You can learn more about fiber optics from our website, our online reference guide, our other YouTube videos,